All right, so for this review, we are going to be using no calculator, so make sure you have your calculator on your desk. So when we first combine integers, we are going to think about the integers as separate integers, okay? So we have -12 and a -3. Because they are both negative, we are able to combine them, which means we're building for the same team. So -12 and -3 is going to be -15. If you look at the next one, -3 and a +9, we're still going to be combining integers, okay? So these ones we cannot combine because they are different signs. So we're going to subtract and take the sign of the larger number. So we're going to have 6, and it's going to be +6 because 9 is larger. 1 minus 9, again, different signs, so we subtract. 9 minus 1 is 8, but there are more negatives left over because that 9 is larger. -6 plus 12, okay, they are different signs again, so we cannot combine them. 12 minus 6 is going to give me 6, and the 12 is larger, so it's going to stay positive. Now, if you look at the second row, there are 2 integer signs in between all of the integers. That means we need to simplify first by dumping doubles. 2 negatives become a positive, and a negative and a positive dumped to become a negative. So we would write this one, rewrite it as 5 plus 2. 5 plus 2 is going to give me 7. All right, this one we'd rewrite. We would dump those doubles, and it becomes -4 minus 7. Okay, we're building, they're the same sign, we're building for the same team. So if I have -4, -7, I have 11 total negatives, excuse me. All right, -9 plus 6 is what this one becomes. There are 2 different signs, so we are battling, okay, which means we're subtracting. 9 minus 6 is 3, and that 9 is bigger, so we keep the negative. And the last one, 8 plus a -9, we're going to simplify to be 8 minus 9. That 9 is the larger number, so we're going to keep it negative, and 9 minus 8 is just 1. All right, when we talk about integers with multiplication and division, I like to use the sleepy old man. You certainly don't have to if you've memorized the rules, but it is a good strategy or mnemonic device in order to help us remember what a positive times a negative or a negative times a negative is. So if you look at the first one, 2 times 3 is 6, right? Positive times a positive is always 6. -12 divided by 3. So the way the sleepy old man works for this is we're going to take that -12 and cross off one of the negative i's, and then the +3, cross off the +3, and whatever sign is left over is going to be the sign of my answer. So 12 divided by 3 is just 4. The computation part stays the same, but the positive divided by the negative is going to be a negative. Okay, let's look at the next one. So we have, again, our sleepy old man, a -4, so we're going to cross off a -4, and a -7, cross off a -7. Okay, so 4 times 7 is going to be a positive, -4 times -7 is going to be a positive 28. 20 divided by 10, those are positives. So what is 20 divided by 10? Just 2. All right, let's see, -9 times +6 is going to leave me with -54. Okay, and our last problem on there, -81 divided by -9 is going to be a positive 9. Okay, great job. So now let's move on to absolute value. Absolute value's definition is how far away something is from 0, or the distance away from 0. Okay, so if we were to look at this number line, we would say that what is the absolute value of -6? Well, -6 is 6 away from 0. So the absolute value of a negative number is always a positive. Same thing, if we said, well, how far away is 6 from 0? Well, it's 6 away. So the absolute value of 6 is also 6. A lot of times people think it's the opposite, but it's not. Absolute value is just always, 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 always positive. Now, if you have 2 numbers inside of an absolute value bar, it works as grouping. So we have to do the grouping first. All right, so we're going to solve what's inside the bars first. So -7 plus 4, think back to your integers. We're not going to be able to combine these, so we subtract and we get -3. The absolute value of -3 is +3. All right, the absolute value of 7 minus a -4, we're going to dump our doubles. So we have 7 plus 4. 7 plus 4 is going to be 11. The absolute value of 11 is just 11. All right, if we keep on going, we're going to talk about our properties. Properties really make, it would make it easier if we could remember what the root word means to help us identify which property we are trying to determine. So for commutative, the order changes, or it changes order. I always think CO, change order. Okay, so if we were talking about commutative of multiplication or addition, we would say that A plus B equals B plus A. Or you could say A times B equals B times A. The order is just changing. Now, if we talked about associative property, the order stays in the exact same position. Every number stays in the exact same place. So I could say maybe A plus B plus C equals A plus B plus C, but the grouping is changing, and we show grouping by parentheses. So if I were to group A and B together in the first half of my equation, A and B couldn't be grouped together on the other side. B and C would have to be. So everything stays in the same spot, but the parentheses are shifting. And then distributive property. That number outside the parentheses has to distribute to each of the numbers inside. So we'd say A times B plus A times C. A lot of times we forget about that poor little C in there, but it also needs to be distributed out too. With identity property, identity always equals itself. So it starts as itself. It starts as A. We times it by 1 if we're talking about the multiplicative identity property, and it's going to stay itself. Okay, so you see you have A and A. If we talked about the additive identity property, A plus 0 is still going to be A. It starts as itself and it ends as itself. All right, inverse property. That's when we are undoing something, when we have some type of opposition going on. So A plus, what would A's opposite be? How are we going to cancel it out? Think about an equation. Well, with a negative A. A plus negative A equals 0. Whereas if we were multiplying, we're thinking about the reciprocal because that's its inverse of a fraction. So A times 1 over A equals 1 would be your multiplicative inverse property. You could also say A over 1 times 1 over A. And then finally, zero property is 3 times 0 equals 0. Remember, it's only for multiplication, not ever for adding. Never. Okay, moving on to number 7, powers of 10. When we see a positive exponent, an alert should go off in my brain thinking, okay, I'm talking about a whole number, a big number, not a decimal. So 10 to the 4th is 10 times 10 times 10 times 10, which is 10,000. This is your expanded form. This is your standard form. All right, so 10 to the 3rd would just be 10 times 10 times 10, which is 1,000. And 10 to the 2nd is 10 times 10, which is 100. Again, all positive exponents, so we have big numbers. Now, if we have negative exponents, that does not mean it is a negative number. All it means is that our number should be represented by a fraction or a decimal. So 10 to the negative 1, on your paper it says 0.1, but make sure, or 0.01, but make sure it says this 0.1. I wrote it incorrectly on yours. So 0.1, not 0.01, or 1/10. Again, these are positive numbers, but they have 10 to the negative 1 is a negative exponent, meaning it's a number greater than 0 and smaller than 1. So 10 to the negative 2, we're going to start with our 1. We're going to move once, twice. So 10 to the negative 2 is 0.01, or 1 over 10 squared, or 1 over 100. You might see it in either of those ways. 10 to the negative 4, 1, 2, 3, 4, 0.0001. That 1 is in the 4th decimal place, which matches the exponent. Or 1 over 10 to the 4th. Or 1 over 10 times 10 times 10 times 10. Or 1 over 10,000. All right, so now if we talk about scientific notation and standard notation, you guys do really well with that. We'll just review it quickly. Just a reminder that that decimal has to have one number in front of it, a number 1 through 9. That's your coefficient. So my decimal begins behind the 0, and it moves once, twice, 3 times, 4 times to get between the 7 and the 4. So 7.4 times 10. And again, this is a whole number, so we're using a positive exponent, just like in the powers of 10. With 0.000478, my decimal needs to go in between the 4 and the 7 again. but I'm moving 1, 2, 3, 4 times to the right, and it is a decimal, which means we're using a negative exponent. So decimals get negative exponents, whole numbers get positive exponents. All right, for scientific notation to standard notation, we are going to look at that exponent, see that it's positive, and know that we need to make that a whole number. So I'm going to move to the right, not the left. I'm going to move to the right 5 times. 1, 2, 3, 4, 5, and write my new number, 830,000. 2.8 times 10 to the negative 4 is a negative exponent, so we're moving to the left. 4 times. 1, 2, 3, 4. 0.000298. Okay? And again, to just remind you that positive exponents move the decimal to the right, negative exponents move the decimal to the left. And the very last part to this, you can use a calculator for arithmetic and geometric sequences. Remember, arithmetic starts with an A, as does adding. So we are adding by a certain number every time. So sometimes these negatives confuse people. If you have enough numbers that you can look at just the positives, why don't you? So 6, 15, and 24, what is the common difference? How much space is in between 6 and 15? Well, you could figure that out by doing 15 minus 6, or 24 minus 15. So the space in between 15 minus 6 is we're adding 9. 15 plus 24, we're adding 9. So my common difference is 9. When we ask you to write the rule, we're looking at how are you getting from one term to the next. So we're saying n, any one of these numbers, plus 9. And if you're looking for the 7th term, you just need to figure out, well, how many terms do I already have? 1, 2, 3, 4, 5. So in order to find the 6th term, I'm going to say 24 plus 9, which is equal to 33. Okay, and then I'm going to add 9 to that one more time to find the 7th term. 33 plus 9, what is that? That should give you 42. Okay, geometric sequences, we are multiplying, never dividing, multiplying by a common ratio. So 4, 16, 64, 256, 1024, what are we multiplying by each time? What am I going to multiply 4 by to get 16? Well, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. Always double check that it still works for the next number in your sequence. 16 times 4 is 64. So our common ratio is 4. Our rule would be 4 times n. And what would your 7th term be? Well, you're going to have to take the last number, which is your 5th term, multiply it by 4, see what you get. And then that number you're going to have to multiply by 4 again. Okay, so go ahead and fill out the 7th term. Once you've done this, you can try the rest on your own on the back with no calculator.